Now let's see how we handle the fact of moving our PCs, our resolution step. We will want to have an event which will start with player turn is equal to 2. It means that we are in the resolution step. We'll also add another global variable that is going to be moving pieces, and make sure that it is equal to 0 by default. And in that event 16, there we add another condition, compare variable, and make sure that moving pieces is equal to 1. And the spot in which we are going to change this value from 0 to 1 is actually on touched go, right there, when in a sub-event we check that the player turn is equal to 2, we will set moving pieces to 1. Then we go back to our event, we add another condition in the system, and this time it's going to be a for each loop of piece. And so for each pieces, and finally add yet another condition, pieces is boolean moved, and we invert it. We make sure that is not yet have been moved. Let's get back on this. When the player turn is equal to 2, so we are in resolution, the user has clicked on the go button, so it is time for the pieces to move. We have set our global variable moving pieces, it's set to 1 now. We will repeat the following actions and sub-events for each piece and make sure that those pieces aren't moved yet. And with all those conditions, we then add a sub-event and we check for the current position, so the current X and the current Y, and make sure that it is in a range of 2 pixels around the next X and next Y coordinates we have set it up earlier. So X is less than self.next X plus 2, but at the same time it's greater than self.next X minus 2. So it's in a 4 pixels range from next X. And same thing after with the Y position. Compare Y, self next Y, and self next Y. So if any of those conditions aren't true, this action is not going to be made, and this action, and it's actually, oh, I forgot, just so when we are sure that we are in resolution, that the pieces are supposed to move and that the pieces haven't reached their destination yet, we add an action and set the position of our pieces according to self.x plus, open the brackets, self.next x minus self.cur x and multiplied by dt. So it's actually a kind of mathematical formula to make to change the position each frame. So that's where our multiplied by dt allows us to make sure that whatever the power of your device is, it will move the same on every devices. So it's always going to be the same speed on every devices. It's very interesting in that regard. We'll copy and have the Y position, set Y, and it's for the same, the current y, on which we add the target y minus the starting y multiplied by dt. And so this is a way to have your objects moving in construct. We could have used some behavior or whatever, but we can do it in code, and right under it, once it has been moved, check if the current position is in range of the destination, and when it is, then we set the position of the piece to be at self.next. Actually, we can set the position, not just the x. Let's set the position. Here it is. So self.x, no, self.next x. I'll do it. Next x and self.next y. So now it is in the target position for sure, because the issue, if you will, is that when you are moving the setting the x and y positions in those formulas, you can end with an x value that is not an integer, whereas next x is going to be an integer no matter what. And even if the value is like the value of next x dot 0001, it wouldn't consider that the x is equal to next x. That's also why I'm checking for a range around the destination. So we set the position and we set the piece boolean to moved. It's moved from now on, so it won't move again. I'm making a new sub-event though, and it will allow us to check for when both pieces have moved. System pick all piece. And so for each instance it makes sure that the boolean is not moved. But when I'm saying right there that I want to move a piece, it's moving one piece, and then it's moving one other piece, and then it's moving one piece, it's checking that this piece is in the target position, in its target position or not, and it's doing it again for the other piece. It's not moved, etc., etc. But right there, by using the pick all piece, I'm resetting the picking. And so from now on, under this condition, it means again that when I'm referring to pieces, to the object piece, there isn't any instance picked at that moment, so I can be referring to all the instances at once. It's not exactly what we want again, so we are going to make some picking again, and we will pick the piece that are moved, so that have their boolean instance variable moved set to true. And I want to check also by a system compare to values that piece.pickedCount, you can see there in the help window, get the number of instances matching the event's condition. And so this is what I want. Piece.pickedCount is equal to 2. So that means that I have picked my 2 instances on board, and they are both moved. And finally, I want this to only happen once. So another system event in the special condition trigger once while true. And so it happens once, and I add a blank sub-event. Once it has happened, I want to wait 2 seconds before executing the rest of my actions. I will reset the value of moving pieces to 0, So it means that this event from there won't be executing. There won't be any action anymore. It's over for now. I will reset my player turn, because now it means that it is player 1's turn again, and I'll simply call display transition. And that's how you have a playing loop. If I test right now, I have my player 1 turn, I decide where I want to play. Player's 2 turn, I decide where I want to go. It's now the resolution, it's going. It's not working. What did I miss? Oh yes, here it is. I forgot to get back in this condition to compare the y. That is greater than self next y. Okay, let's try again. Resolution. It works. And 2 seconds later, it's my player 1 turn again, and I can play. And it's my player 2's turn, and I can play, and I have the resolution. Yeah, I forgot. Once again, I forgot something. We are not resetting the moved variable at the moment, you know, so it's on display transition. On display transition, when player turn is equal to 2, we set the pieces boolean moved to false. This way, each time we will display the transition and that we are in resolution mode, it means that we will give all the possible conditions for this event there. Our moving, let's add a comment to make it easier to see. Moving our pieces. So this event which moves our pieces is made possible thanks to those setting of conditions. And if I'm testing, I now have a full loop that works. And you can see how debugging your code also works when you can have an issue or not. So now it's working, but it also means, as you can see, that we are not breaking at the moment the cells, and we don't have winning or losing conditions yet. Normally, as I wanted, it is supposed to have been a draw right there. And this is what we are going to see just right now. So as I was saying earlier, our winning conditions have not yet been decided, and that's what we are going to add to our current code. And it will be a bit all over the place as well, because it's kind of an involved system, but it's also involved within the turn-based system itself. So let's start by adding a global variable that we will name winner. And we will also need another variable that is called destroyed count. Destroyed count. You may or may not guess what it is going to be used for. Oh, winner, the default value is not 0, actually it's -1. It's going to be important and kind of tricky too. We'll have to modify on touched go when player turn is equal to 2. We'll add a sub-event, make it for each pieces, like we did earlier. Pick the cell that is being overlapped by the piece, and this cell we will actually set the frame to self.animation frame and add 1. So we will slowly pass from nothing to a bit broken, quite broken. It's a gap. when the frame is going to be 3. And this will happen each time you are clicking on the Go button on the resolution. So the piece that you are leaving is being destroyed once you are leaving. But as you can also stand on the very same piece, it's going to be broken at the very same time anyway. And it only happens during the resolution. So that's one of the aspects of our mechanic that is going to be important. And it happens when we are clicking on the Go button. And that's about it at that time. Then it's when we are moving our pieces, and actually once we have finished moving, that we will need to have some checks, and we will add a sub-event, yet another for each piece this time, and we are having it again since we've had a pick all piece right there. But we would want this to happen before our blank sub-event. So for each piece, and once again, piece is overlapping a cell. This allows us to pick the correct cell, and finally to check in another condition what is the current frame and if it's equal to 3. So is the target actually a gap? And if it is, we start the fade from the piece. We start the fade, so the piece will fade away thanks to its behavior, and as said there, it will be destroyed once the fade has finished. And another thing we need to do is to set the winner value, and hang on to your hats, piece dot animation frame +1, but it's actually a question. Is it equal to 1? If yes, we set winner to 1. If not, we set winner to 0. And that's how you do a conditional expression, which is one of the nice tricks available in Construct. You don't necessarily need it, but it's always nice to know about it, and it also allows us to set either a value or another in a single line of an action, which is pretty interesting. I could have done the very same thing, but it would have taken a few events. When piece that animation frame, so the piece for each piece that is overlapping a cell, which animation frame is equal to 3. So if a piece is overlapping a broken cell, let's say that, we check its animation frame, we add 1 to it. If the answer is equal to 1, we set winner to 1, otherwise we set winner to 0. Let's go on. Another condition, another winning or losing condition in a sub-event is when a piece is overlapping another piece. And in that very case, so once again, we go over there, we will use the same actions. So I can control, select them, drag, drop, here it is. And in this case, winner is going to be 2. I need to add another event, and that is going to be on piece, destroyed, on destroyed. And I will then add, right there, add to destroyed count 1, which is the point of the destroyed count. So okay, I have a start of handling of those things. The final and complete handling of the condition, of the winning condition or losing conditions, happens in the display transition part, because it's where I will want to show our players what happened, and finally it's where it's displayed. So on player turn is equal to 2, it's okay. I will check for a draw, and so I will add another condition, not another condition. I will add a sub-event, which is going to be when destroyed count is equal to 2, which means that both pieces have been destroyed, and so it's a draw because they have disappeared. And I will want my txt transition frame to be equal to 4, which should be a draw, and I will then set the winner value to 2, which is a draw. So let's check out in transition. Player 1 frame 4, player 1 wins, player 2 wins, or I'm missing the draw. So let's add a frame. Let's open it. It's txt draw, it was missing, and it's the value, it's the frame number 4. So 4, 5, 6. Now we are good. It's working. Then add another sub-event. When we are going to check when winner is not equal to -1, so it is not it is finished, and winner is actually not equal to 2 either. It's finished and it is not a draw. And in that case, I will want to set the animation frame to winner plus 5, because winner is going to be either 0 or 1. And as you have seen right there, our frames to say if the player, which player has won, is either 5 or 6. So if the player 0 wins and I add 5 to player 0, I will have the frame number 5. But if the player 1, in our logic, you know, winner, player turn, so 1 plus 5 is equal to frame 6, player 2 wins. It does the trick. On touched go, add a sub-event when winner is not equal -1. So whenever it's 0, 1 or 2, whatever the case, it's the end of the game. So right now, with what we have of our code, I will just want to reset the global variables and restart the layout. That's it. To have a full loop, just restart the layout. It's going to be a bit buggy, but we will see in the next part how to go over this. And that does the job. Let's check it out. Player 1 turn, player 2 turn, resolution. This works. It breaks the cells, and if both are drawing, it's a draw, and we start over with the player 1. Nice. And now let's check for player 1 victory. And let's check for player 2 victory actually. It's going to be more interesting this way. Player 2 wins. And now let's test for player 1 victory. It's a draw. It's a bug due to the reset of the global variables that is not correct. I was aware of it in a previous version I've recorded. But it does the job anyway, and once we will have added the menu and the AI, it will work better, and it will work fully as intended. For now, bear with it, hopefully. Hope you enjoyed so far, and see you in the next video.